In section 12.5, we're going to cover permutations and combinations. So, what are we doing today? You are going to learn the formulas for the number of permutations and for the number of combinations. So let's start with a permutation. So what is a permutation? A permutation is an arrangement of objects in which order is important. For example, list the 6 possible permutations of the letters A, B, and C. Well, you can see they're right here. Order does matter. So there are 6 possible permutations of A, B, and C. Now, how do we get that? Well, if you think about it, we have 3 spaces. If I have 3 letters, how many letters can I choose for the first space? 3. But now I can't choose it again. So how many letters are left? 2, and then I have 1. So if you multiply them together, 3 times 2 times 1, that gives you the 6 possible permutations. That is a permutation. So in example 1, consider the number of permutations the letter in the word July. And how many ways can you arrange all of the letters? And B, just 2 of the letters. So in A, you should have in the past done something called the fundamental counting principle. The fundamental counting principle says this. I think I have a little cheat sheet on that. Here it is. Remember, the fundamental counting principle is if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events occur is m multiplied by m. The fundamental counting principle can be extended to 3 or more events. So think about it. If I have 4 letters and I can arrange them in any order, how many letters can you pick for the first space? 4. We're using the fundamental counting principle. Multiplied by 3 letters left, multiplied by 2, multiplied by 1. So there are 24 ways that we can arrange the 4 letters in the word July. In B, I just want the 2 letters, the first 2 letters. So that's going to be, only 2 spaces. Well, there's still 4 to choose from and then 3. So then there's 12 ways to arrange 2 of the letters in July. In example 1a, you evaluated the expression 4 times 3 times 2 times 1. This expression can be written as 4 factorial. For any positive integer n, the product of integers from 1 to n is called n factorial and is written as n factorial, and so you take that number, multiply by the 1 less than it, multiply by 2 less than it, and so on. So if I had 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. As a special case, the value of 0 factorial is defined to be 1. Now an example in 1b, you found the permutations of 4 objects only taking 2 at a time. So here's your formula to deal with that. The number of permutations of n objects is given by this. So, this is our formula. We read this as n permute n, or 4 permute 4. So here's how it works. If I have n objects, that is given by n factorial. So 4 permute 4, that means we're permuting all of the numbers. It's just 4 factorial. 4 multiplied by 3 times 2 times 1. However, the number of permutations of n objects taking r at a time, where r is less than or equal to n, so let's say we're not choosing all of them. Like in part B, we had 4 letters, but we're only choosing 2. It would be n permute r, which is equal to n factorial, divided by n minus r factorial. So we have 4 factorial divided by 4, only taking 2 at a time. Now notice that anything divided by itself cancels. So on top we have 4 times 3 times and then 2 factorial times 2 times 1. On bottom would just be 2 times 1. So the 2 times 1 on top and bottom, otherwise known as 2 factorial, cancel. And you're left with 12. Something to make note of is that you can use this in a graphing calculator. You do have a button where you can do 4 permute 4 or 4 permute 2. And if you need help finding that in class, I can show you. So in example 2, 10 horses are running a race. And how many different ways can the horses finish first, second, or third? So that means we have 10 horses, but only 3 places. So I would write this as 10 permute 3. That would equal 10 factorial. And then we'd subtract 3 from 10 factorial. That gives me 10 factorial over 7 factorial. And if I simplified that, 10 multiplied by 9, multiplied by 8, multiplied by 7, 6, and so on. But that'd be 7 factorial, which means the 7 factorials can cancel. So you would multiply 10 times 9 times 8, and 10 times 9 times 8 gives you 720, and therefore there are 720 ways for a horse to finish first, second, and third. In example 3, we're going to be finding probability using permutations. So now we're going to do probability. So probability for a town parade, you will ride on a float with your soccer team. There are 12 total floats. So first off, there are 12 total floats. So let's do 12 permute 12 to find the total number of possible ways we can go. Well, 12 factorial will be our denominator. Now, we want to know there are 12 floats. Their order is chosen at random. Find the probability that your float is in first and the float with the school chorus is in second. Well, I can do the complement here. Write the number of favorable outcomes as the number of permutations of the other floats, given that the soccer team is first and the chorus is second. So that'd be 10 permute 10, which is 10 factorial. So I can take 10 factorial divided by 12 factorial. So I can set it up like this. The 10 factorials cancel. So this probability would be 1 over 132. Now let me just go over once again permutations. You've done permutations. I'm now going to teach you about combinations. If you are given, like comparing something, and you have to put things in a certain order, then you're going to use the permutations formula. If order is not important, you're going to use the combinations formula. So a combination is selection of objects in which the order is not important. For instance, in a drawing for 3 identical prizes, you would use combinations because the order of the winners would not matter. If the prizes were different, then you would use permutations because the order would matter. So let's look at example number 4. I want you to count the possible combinations of 2 letters chosen from the list. So we would list all the permutations of 2 letters, in which right here, order would matter. So we're going to list all the permutations. Now, because order is not important, we can cross out any duplicate pairs. So as you can see, AB and BA, they're the same thing. So I can cross off BA because order doesn't matter. So I can cross off one of those and so on. So if I cross them out, you're left with 1, 2, 3, 4, 5, 6. 6 possible combinations of 2 letters from the list. Now in example 4, you found the number of combinations of objects by making an organized list. You can also find the number of combinations using the following formula. Now you'll notice this is what a graphing calculator can use as well. The number of combinations of n objects taken r at a time, where r is less than or equal to n, is given by this. We would read this as n choose r. N choose r. So for example, the number of combinations of 4 objects taking 2 at a time, when order doesn't matter, remember that. You'd have 4 factorial over 4 minus 2 factorial, same thing, but now we just multiply what we're choosing. So multiply by 2 factorial. That's it. And there's how you'd set it up. The 2 factorials would cancel, so that'd be 12 divided by 2, which is 6. Example 5. You order a sandwich at a restaurant. You choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? It doesn't matter the order. So we're going to do 8, choose 2. That means 8 factorial divided by 8 minus 2 factorial multiplied by what we're choosing, which is 2 factorial. So on top, that would be 8 factorial divided by 6 factorial times 2 factorial. So I could set that up as 8 times 7 times 6 factorial divided by 6 factorial, which is going to cancel, and then 2 factorial is just 2 times 1. So that would be 56 divided by 2, which gives me 28 different combinations. Example 6. A yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Well, the first thing we do is it doesn't matter the order, so we're going to do 14, choose 2. So you have 14, you are choosing 2. So that would give us the total number of ways. So 14 factorial divided by 14 minus 2 factorial multiplied by 2 factorial. That would be 14 factorial divided by 12 factorial multiplied by 2 times 1. That would give me 14 times 13 times 12 factorial divided by 12 factorial times 2. The 12 factorials cancel, so that gives us 14 times 13 divided by 2, which gives me 91. So that means there are 91 total ways. Find the number of favorable outcomes. Well, there's only one of possible combinations with you and your friend. If you're picking 2, there's only one combination. So that would be 1 over 91. So you have a 1/91st chance of getting your friend and your photo picked. And here are the 2 vocab words for this section.